Welcome back to another video. On the bench today we have got a circuit board, a EBX1005G02, which from a quick Google looks like it's from an LG inverter drive refrigerator. The problem with this board is, well, let's try to take you in a bit. Let's see if this will show. Microchip over here, this IC, which is a switch mode controller type chip there. As you can see, it's got a nice little air vent in the top there. It's got air conditioning, okay? So I don't think it's supposed to have air conditioning there. That is the TOP225Y, which is the basically, here's it, there, TOP225Y, which is the switch mode, basically power supply section of this board. So what I want to do before I get another one of those chips is I want to pull this out. I want to try power the board and see if there's any life. See if this main microprocessor here is working or if it was toasted. Because if this is toasted, then basically it's a whole board replacement. If it's just the power supply section, then we can work on it from there. So I'm going to work on pulling out this chip here, and then we can take it from there. Okay, so I've cleared out where that switch mode controller chip was. Okay, I've left the heatsink in place. I might move it later to clean this section if I need. Okay, now looking at the output of the switch mode transformer, which is here. Looking on the output side, you've only got two sets of terminals really. You got this one and this one looks like it's on a ground plane. So this is most probably your negative. And if I look over here, after this diode, you got some positives. Some capacitors, not positives, capacitors. If you look at the negatives of the capacitors, they are on the ground plane. And if the positive between the capacitors, you can see they just got that little bridge between them. So that's on the ground plane, that negative of the capacitor on the ground plane. And this is the common side sink. This is a negative, and that would be the positive. And it's just a single supply. And if I look on the board here, I don't know if you can see that. Doesn't want to focus too well. But on here it says common 12 volts, common DIDO. And then if I look at the relays on the board, they are also 12 volt relays. So my guess is that this is a 12 volt power supply, and then later it gets stepped down as it goes to the main microprocessor. So basically I don't want to put 12 volts in on this side because I don't know what type of protection they've got. I'd rather put 12 volts in on the capacitors, because then I know that's straight after this diode here from the transformer. So I'm going to do that now. It is a bit fun because of the conformal coating that's causing the solder to stick all over. But let's give it a go and see if this board has any life. Okay, so there I've got my negative on the ground plane section, my positive on the positive of the two caps. Let's clean it basically. Okay, I don't know if there's any LEDs on here. Why should there be? I mean, it's inside a fridge. But maybe the relays will click, or maybe there's an LED that we'll see in a few seconds. So let's prop it up. Let's see what happens. Okay, I did see a small spark when I connected up the supply. Obviously I'm not seeing anything on the board, and my multimeter probes have decided to turn into bare wires. Cheap Chinese junk, but anyway. See if I'm getting 12 volts out on this connector. it says common 12 volts, COM 12 COM DIDO. So common and plus 12. Okay, so I am getting plus 12 out there. I wonder if there's somewhere where I can see a 5 volts. Oh, did you hear that? I just heard a relay click. Hey, it's and click on a delay. Obviously that didn't happen right away, so it could be that the processor told it to activate. And that's nice thick rain we got outside there now. So I'm just disconnecting my supply. Common and 12, make sure there's nothing. Okay, let me... Like I said, it's drawing current. And one of these relays did click after a certain amount of time. Just a watched relay never to click. I've got my fingers on all the relays to try to figure out which one is clicking. And it does. Or maybe the circuit didn't discharge enough to reset the processor. Let me see if I can get a resistance on the relays. That's neutral. It's common. Neutral. Okay, let me shut this down completely. Wait for it to discharge. Check the fusible resistor. Fusible resistor is fine. Fuse. Onboard fuse. Onboard fuse is nice and open. So that'll have to be changed as well. Okay. Let's see. The reservoir capacitors. Oh, here are the bulk capacitors. Okay, there's a nice little bridge rectifier collection over there of diodes. Don't know if you can see that there, just under where my finger is. So the power comes in, goes through this common mode choke, do those bridge rectifiers and charges up the capacitors. Then this little chip over here runs this transformer, powers the side of the board with a little feedback opto isolator there that talks back to the chip to control the voltage output. I do see things that look like bubbles on some of these optos, but that's fine because that's just their conformal coating. So let me put this back up to 12 volts again. So I want to hear or see which relay clicks. They really should have put a status light on this thing. Maybe I can check for power on one of these other chips. Because this one looks like a custom GEA main 50M. But this looks like just a MC 3479P. Oh, by the way, the MC 3479P is obsolete, in case anybody wants to design with it. Don't. All I want to see is if I'm getting 5 volts there, I think. So I'm going to go onto the VM, which is 16, and then 13 should give me ground. 13, 12, 4, and 5. – 16, 13, 12, 4, and 5. 16, 15, just get my color right, 16, 15, 14, 13, and that's 12.2 volts. Okay, and if I look at the data sheet, it says supply voltage 18 volts. Okay, so that doesn't help me see if I've got a 5 volt rail on here. Okay, so what I've done now, I figured out, let me just hook up to a decoupling capacitor near the processor. Of course, it's all conformally coated. That looks kind of funky. So I've got a capacitor over there that I just tinned a bit of solder onto each side of, okay? So let me take you out so you can see the screen there. And that's just South Africa's national load shedding has started. Yeah. And there you go. Well, let me swap my wires around so you don't complain about me having negative voltages. See, 5.03. So the 5 volt regulation is working. Just wish I could see if the processor was working. Okay, let me see if there's some way without my scope to see if I get anything on this processor. Just to see if the processor is running. If the processor is running, which I did a click earlier on, then maybe it's just replacing that chip would sort it out. I'll be back. Okay, so what I did now is I installed software on my laptop called Exoscope for Linux, for Ubuntu. Basically it's a sound card oscilloscope. As you can see, it's picking up a whole bunch of noise. It's using the microphone inputs on the laptop down there. Okay, and I've got just joined onto a probe over here, and if you see, if I ground it onto this connection, the screen shows a lot flatter line until it automatically gains up. But now if I go and touch it on the board, listen here, if I touch it on this data in or data out, you hear a relay clicking. So it could be that the microprocessor is interpreting the bias voltage from the microphone circuit as an input signal. And it's got a slight delay before it reacts, so that's good. So now I want to see if I can get this oscillator here, which is near the processor. That's definitely looking like something. course, if it is the oscillator running, it'll probably be faster than my laptop can pick up. But at least we're getting some sort of signal. Whoa. I got something on that little chip. There's another little chip I'm probing here. What if that comes straight away with power? Looks like initialization, and then so as soon as I put on power, and then it starts to tick. So it looks like it could be a memory chip that it's talking to there. That is the very first one, so the auger is kicking in. Like I said, I don't think there's a direct relation between here and that driver for the relays. Probably just a Darlington array or a shift register, because it has to go through all this through the processor. Even here, if I hold this on and I hook on power, that relay only clicks in after a while. So I think processor should be fine, which means the low voltage side of this board should be fine. Hopefully the transformer's fine. I'm going to check the rectifier diodes now, make sure they're in order. If they're in order, then I might just need to get one of those chips, which I don't think I have, but if I do, or if I can get one, might be in luck. Okay. Okay, welcome back to the continuation of this refrigeration board. Off camera I did some work as well. I don't know how far we got, but basically whenever I replaced the fuse, even with this chip gone, it would blow the fuse again and again. After tracing my way through, I found out one of these diodes was shorted, so I changed it just to normal 1N4007s with the legs folded over there. That's nicely connected. Also found out the capacitors had it, the reservoir capacitors. Took a lot of force to get these two out, and I had to do some touching up on the board there and fix a trace because of that. And you can see I've got a jumper over there. And basically we need to just change some parts. So we need to change the fuse, we need to change, well, I've already changed those diodes, I said. We need to change those capacitors, put that chip in. I've also got some opto isolators. I think we'll change these opto isolators as well, because they were all near that section where the DC had failed. Sorry, all there, the section where the diode had failed and was conducting the DC all the way through. So yeah, that's how far we got. So I think it's time to start changing parts. Changing parts. Yeah, so I've got optos. I've got opto isolators and not the surface mount. Whoops. I've got some diodes as per the data sheet for that chip. So you need some of these diodes and some of these diodes and things like that. So those two need to go in. Got the new capacitors, got some fuses, and got the new 100 South African Rand switch mode control chip. So, time to start swapping things. We're going to test it and see how we go. So I'm just going to replace these parts quickly and then I'll be back. I could change some resistors over here on this feedback path before the opto to nudge it back down to 12 volts on the nose, but like I say, the circuit's been working fine like this, so obviously they've accounted for that because I'm using the exact same part number and everything, so I don't think this is going to be a problem. Make sure that's not getting warm. No. Okay, because I couldn't find exactly the same the TOP225YN, so I've gone for the 224YN. Slightly lower wattage, but I mean it's got a nice chunky heatsink, and I don't think this circuit draws more than 2 amps anyway. So I think this thing might be good to go. Five volts there. So what I'm going to do is I'm going to leave this one on a soak test, just basically plugged in for a few hours. Make sure nothing else goes wrong, make sure nothing blows up or gets too hot. Then I'll just give it a brush with some alcohol and a toothbrush or some Q-tips and give it a nice spray of clear lacquer just to protect it. And then if all that's good, I guess they can take it and try put it in and see what happens. So hope it works. Hope you enjoyed this video. If you liked it, give it a thumbs up and share if you want to.